Imagine standing on a frozen alien world, hundreds of light years away from Earth. The sky above you is not like our sky. There is no single sun rising over the horizon. Instead, the darkness begins to glow from two different points. One star burns larger and orange. The other is smaller, dimmer, and red. Together, they climb into the sky, casting strange double shadows across the surface.
And when night finally comes, the sunset does not happen once, it happens twice. This sounds like a scene from science fiction, but NASA has confirmed that planets with two suns are real. Welcome to Infinite Science, where the universe keeps proving that reality can be stranger than imagination.
The planet is called Kepler 16b. It is one of the most famous alien worlds ever discovered because it orbits not one star, but two. Scientists call this a circumbinary planet. That means the planet does not orbit just one sun the way Earth orbits our sun. Instead, it travels around two stars that are also orbiting each other. Picture two stars locked in a gravitational dance. They circle a shared center of mass, called a barycenter. Around both of them, far outside their stellar dance, a planet moves in a wide orbit. That planet is Kepler 16b. For decades, scientists wondered if such planets could exist. A planet around one star is already shaped by powerful gravity, radiation, and orbital motion. But a planet around two stars faces a much more complicated environment. The gravity is not simple. The light is not steady. The stars are constantly changing position. The planet must survive the pull of two suns at once. For a long time, astronomers thought these systems might be too chaotic for planets to form and remain stable. Then NASA's Kepler space telescope changed everything. Kepler was launched to search for planets beyond our solar system. These planets are called exoplanets. Kepler did not take close-up pictures of alien worlds. Instead, it watched the brightness of distant stars. When a planet passes in front of a star from our point of view, it blocks a tiny amount of starlight. That small dip in brightness is called a transit. It is like seeing a bug fly in front of a flashlight from far away. You may not see the bug clearly, but you notice the light dim for a moment. That tiny dimming can reveal the presence of a planet. But Kepler 16b was even more complicated. The two stars in the Kepler 16 system eclipse each other. Sometimes the smaller star passes in front of the larger star. Sometimes the larger star blocks the smaller one. These eclipses create regular dips in brightness. But scientists noticed something else. There were extra dips that could not be explained by the two stars alone. Something else was crossing in front of them. Something was orbiting the entire system. That object was Kepler 16b. In 2011, NASA announced the discovery. A real world with two suns had been found. Many people immediately compared it to Tatooine, the fictional home planet of Luke Skywalker in Star Wars. But Kepler 16b is not a warm desert world. It is not a place where humans could walk under two golden suns. The real planet is much colder, darker, and more extreme. Kepler 16b is a gas giant. That means it is more like Saturn or Jupiter than Earth. It probably does not have a solid surface you could stand on. NASA lists it as about 0.75 times the radius of Jupiter and about 0.33 times the mass of Jupiter, so it is roughly Saturn-sized. But its environment is very different from Saturn's. Kepler 16b orbits its two stars every 228.8 days. That is surprisingly close to the length of a Venus year in our own solar system. But even though Kepler 16b orbits at a distance similar to Venus's distance from the Sun, it is far colder. Why? Because its two stars are smaller and cooler than our Sun. The larger star is a K-dwarf, about 69% the mass of the Sun. The smaller star is a red dwarf, about 20% the mass of the Sun.
Together, they do not produce the same warmth and brightness that Earth receives from the Sun. So Kepler 16b lies outside the comfortable habitable zone. It is not considered a likely home for life.
But that does not make it boring. In fact, it makes it one of the most important planets ever discovered, because Kepler 16b proved that planets can survive in places once thought too unstable. It showed that nature can build planets around two stars, and that changed the way scientists think about the galaxy. Many stars in the Milky Way are not alone. They are part of binary or multiple star systems. So if planets can form around two stars, then the number of possible planetary systems may be far larger than we once imagined. The discovery expanded the search for alien worlds. It told scientists that they should not only look around single stars like our Sun, they should also look around stellar pairs. Somewhere out there could be planets with two suns that are rocky, planets with oceans, planets with atmospheres, planets that orbit in the habitable zone. Planets where the sky changes in ways Earth never experiences. Imagine life on a world like that. Every day would be shaped by two stars. The color of daylight could shift as the stars moved. The shadows could split and overlap. The seasons could follow a rhythm far more complex than Earth's. Sunrises might come in pairs. Sunsets might stretch across the sky in two different colors, and eclipses could be common. One star might pass in front of the other, dimming the entire world for a short time. To life forms on such a planet, this would not seem strange. It would be normal. Their biology, their calendars, their weather, and their sense of time could all be shaped by a double star sky. That is one of the most fascinating ideas in astrobiology. Life does not have to evolve under one sun. Earth did. But the universe does not have to copy Earth. A planet around two stars could have its own kind of day and night, its own climate patterns, its own evolutionary pressures, its own version of normal. Kepler 16b itself is probably not alive. It is a cold gas giant. But what if a planet like it had a large rocky moon? In our own solar system, gas giants have moons that are scientifically fascinating. Jupiter has Europa, which may hide an ocean beneath its icy crust. Saturn has Enceladus, which sprays water-rich plumes into space. So when scientists find gas giants around distant stars, they also wonder about moons. Could a moon around a circumbinary gas giant have conditions worth studying? Could it receive enough energy from starlight, tidal heating, or internal activity? Could it hold an atmosphere? Could it have liquid water? These are still open questions, but Kepler 16b forces us to think bigger. It reminds us that a planet does not need to look like Earth to teach us something important. Sometimes the most valuable discovery is not a world that looks habitable. Sometimes it is a world that proves the universe can build something we thought was impossible. The sky on Kepler 16b would be unforgettable. The larger star would glow orange. The smaller red star would follow it through the heavens. Because the stars orbit each other every 41 days, their positions in the sky would constantly change. Some days, the two suns might appear close together. Other times, they would separate. Sometimes one would block the other. And from the planet's orbit, the entire system would feel alive with motion. This is not the still, simple solar system model many people imagine. This is a moving gravitational machine. Two stars orbiting each other. A giant planet orbiting both. Eclipses, transits, changing light, shifting shadows. A cosmic clock built from gravity. And Kepler detected it from Earth's neighborhood by measuring tiny changes in starlight. That is what makes the discovery so powerful. We did not travel there. We did not photograph the surface. We measured light, a slight dimming, a repeated pattern, a gravitational clue. And from that, scientists reconstructed an alien solar system. This is how modern astronomy works. The universe sends us light, and we learn how to read it. A planet crossing a star becomes a signal.
An eclipse becomes a measurement. A wobble becomes a clue. A pattern becomes proof. Kepler 16b is located about 245 light-years away. That means the light we see from that system today began traveling through space centuries ago.
When that light left Kepler 16, people on Earth had no spacecraft, no exoplanet catalogs, and no idea that planets around other stars would one day be confirmed by the thousands. Now we know the galaxy is filled with worlds. Hot Jupiters that orbit close to their stars, super-Earths larger than our planet, mini-Neptunes wrapped in thick atmospheres,
Lava worlds, ice worlds, rogue planets drifting without stars, and circumbinary planets where two suns rise and set. Kepler 16b is part of a larger message. Our solar system is not the only blueprint. It is just one example. The universe has many designs.
Some are familiar, some are hostile, some are beautiful, some are almost impossible to imagine until science finds them. And every time we discover another strange world, our definition of planet expands. Before Kepler 16b, a planet with two suns seemed like science fiction. After Kepler 16b, it became science fact. That is why this discovery matters. It did not just reveal one alien planet. It opened a new category of planetary systems. It proved that binary stars can host planets. It showed that stable worlds can exist in complex gravitational environments. And it pushed scientists to search for even more unusual systems. Somewhere in the Milky Way, there may be a rocky planet orbiting two suns. It may sit at the right distance for liquid water. It may have clouds, oceans, storms, and continents. Its sky may glow with two stars. And if life exists there, it would see the universe differently from us. For humans, one sun is normal. For them, two suns would be normal. A single-star sky like ours might seem empty. That is the humbling part. Earth feels ordinary to us because it is home. But from the universe's perspective, every world is strange in its own way.
Kepler 16b reminds us that nature is not limited by human imagination. The galaxy is not built to match our expectations. It is built by gravity, time, chemistry, and chance. And sometimes, those forces create a world where two suns set over the horizon. So the next time you watch the sun disappear below Earth's horizon, remember this. Somewhere far away, beyond the reach of any human spacecraft, there is a planet moving through the light of two stars. A frozen giant circling a binary sun. A world where the sky changes constantly. A world where sunset is doubled. A world that once sounded fictional until NASA found it. Kepler 16b is not just a planet. It is a reminder that the universe is bigger, stranger, and more creative than we ever expected. And we are still at the beginning of the search. Thanks for watching Infinite Science. If this story made you see the universe differently, subscribe for more deep space discoveries, strange planets, and mind-expanding science. Because somewhere out there, another impossible world is waiting to be found. Until then, keep looking up. The universe is infinite, and so is the science.